Okay, so now we've got compound interest. So what that means is that whenever the loan or the interest bearing uh, entity establishes when they're going to compound interest, that's when you get more money. Okay, in this case, it is compounded each year. So at the end of each year of leaving your money with this bank or whatever, um, um, another 14% of what was there is tacked on. So in this case, she's not making money. She took out a loan. And so she borrowed 2 grand and now it's just getting bigger and bigger. And she's not making any payments on it. If she does, then we got to use a really different formula and it kind of makes things a little trickier. So let's see what we can do here with that. Let's just go to the calculator. I think that'll actually work quite well for writing it out. So she's got $2,000. And after 1 year, we're going to add to that 14% of $2,000. Now that 14% of $2,000, that's going to be the interest. Okay. So $280 of interest she has accumulated. Okay. So now she owes $2,280. Now, at the end of the second year, this is part B of the problem, it's going to be the same thing, except now interest is calculated off of how much she has at the beginning of that second year. So $2,599.20 is now what she owes at the end of the second year. So she picked up $280 worth of interest in the first year. And in the second year, she picked up another $319.20. So the amount of interest just keeps going up and up. That's the nature of exponential growth. So that's kind of how it goes. Now, you could just say, well, no, wait a minute. This is just an exponential growth problem. So we could just do our initial value times, and then one, let's see, the debt is growing, so I'll do plus, it's not shrinking, 14%. And then you could just say, all right, well, how many years do we want to do? Let's do 2 years. Okay, 25, 99, 20 is what it is. And you could just have that function there. Or you could even just put it right here as 1.14 raised to the x. And then if you go to the table, you say, all right, after 1 year, 2280 is owed. And after 2 years, 25.99. After 3 years, 29.63 and 9 cents, and so on. I can see the value down here. Anyway, so that's what's going on. Okay, so suppose that 2 grand is invested at a rate of 5.5% compounded semi-annually. Now, the last one was annual. On this topic, it's not always going to be annual. So we're going to modify the exponential growth formula to look like this, to be the formula for compound interest. Okay, that's the formula. P is the principal amount borrowed or loaned or whatever, the beginning amount. So 2,000. A is the accumulated, accrued, or final amount. R is interest rate, no surprise there. T is time, always measured in years. And N is the number of compounding periods in 1 year. Now, in this case, we start off with $2,000 at 5.5% interest, so 0.055. And they say, what's the total amount after 7 years? Well, what's our N going to be? Well, interest is compounded every semi-annually, okay, every half a year. That means it's going to be every 6 months, twice a year. Okay. And so that would be the setup. And of course, the final amount of money is going to be more than 2,000 because it's growing. But it's not going to be a crazy amount more. It's only 7 years, and it's a pretty realistic interest rate of 5.5%. So that's going to be $2,923. It says near a cent, so that would be 99 cents. Okay, that's how it's done. Now, just real quick, what if? Oh, wait, I thought I got that. What if it was interest compounded quarterly? Quarterly. Well, there's 4 quarters in anything. 4 quarters in a dollar, 4 quarters in a gas tank. If something's divided into quarters, there's 4 parts. So n would be 4. Annually means once a year. So n is 1. Hey, I planted my annuals, my flowers, and they come up once a year. Anything else here? Quarterly. Okay, if you had daily, that would be 365. If you have monthly, that'd be 12. So yeah, that's about it.